The plant cell wall is one of the most important structures on Earth, not only because it provides the much needed timber in our daily life, it can also serve as an important carbon sink to tackle global warming. Now, the structure of a plant cell wall is highly dynamic because it's constantly being loosened up and re-stiffened to allow the cell to grow. Now, this flexibility is conferred by the highly complex structure within. In general, the cell wall consists of two main polysaccharides, cellulose and pectins. The biomolecular interactions and architectures of these polysaccharides are still not thoroughly understood. Take pectin for example, which is routinely used as an additive in the food to create a gel-like structure. The pectin polysaccharide is a polymer that is constructed using various monosaccharides, such as galacturonic acid, rhamnose, or arabinose. More importantly, there are a lot of modifications on the side chain which make the understanding of the structure even more difficult. Traditionally, to analyze cell wall components, the cell wall is extracted using organic solvents such as ethanol, and the linkages between the monosaccharides are then hydrolyzed to release all the monosaccharides for GCMS analysis. Now, this method, although is quantitative, it doesn't provide the structural information of cell wall polymer, and important information of their native architecture is lost during the extraction process. It is a bit like disassemble a Lego built house and trying to figure out how it looks like before by looking at the type of Lego bricks you have. Technical breakthrough came a few years ago with some chemists start to exploit solid-state MMR techniques to look at plants which have been grown in the presence of 13C or 15N isotopes. Without extracting the plant cell wall polymer, it is possible to visualize the changes in cell wall structures by looking at the 2D spectrum generated using an MR data. Now, this spectrum shows the overlay of a wild type and a cell wall mutant, and it's clear that the siloglucans polymer in the cell wall mutant is deviating from the wild type as marked by the dark color contour here. Furthermore, by improving the MR sensitivity using dynamic nuclear polarization, it is even possible to perform this analysis without using any isotope. Now, as far as I know, that such a technique is still not available in Taiwan, and as a plant biologist, I'm unable to develop it. So the question is there any chemist out there who is up for a challenge?